Hello everyone, myself Radhika Kacharia, Assistant Professor at Department of Pharmaceutical Chemistry at LJ Institute of Pharmacy. Today I am going to discuss Haworth synthesis, which is the synthetic method for the preparation of polynuclear aromatic hydrocarbons. Polynuclear aromatic hydrocarbons name itself suggests that it contains more than one nucleus. It means more than one aromatic ring, and it has only hydrogen and carbons in its structure. Polynuclear hydrocarbons are isolated from the environmental pollutants like coal tar and other pollutants, and the polynuclear hydrocarbons are non-polar in nature and solid in state. It is the colorless white and yellow color powder form. The polynuclear hydrocarbons are classified into two subclass, which is benzenoid and non-benzenoid. Benzenoid means it contains benzene as a fused aromatic ring, and non-benzenoid means it contains other than benzene rings. Now the benzenoid class further classified into two subclasses. One is isolated cyclic rings and another one is a fused cyclic rings. These are some primary examples of the polynuclear aromatic hydrocarbons. First three are from the fused cyclic aromatic rings and another two are from the isolated cyclic rings. Today we are going to discuss the Haworth synthesis, which is used for the preparation of fused cyclic aromatic rings. Here some steps are enlisted from the Haworth synthesis, in which the step 1 is Friedel-Crafts acylation, in which the acylation of unsubstituted aromatic rings happen in the presence of aluminium chloride. The next step is Clemmensen reduction, in which the aldehyde and ketone groups are reduced in presence of zinc amalgam. Zinc amalgam is nothing but the zinc mercury. And the third step is elimination of water in presence of sulfuric acid, and it is known as cyclization reaction. The one water molecule is eliminated from the third step and the cyclization of the whole ring is happened. And next step is aromatization of the cyclic rings. Now we are going to discuss one by one synthesis of fused cyclic aromatic rings. Now we are going to preparation of naphthalene by using Haworth synthesis, in which the unsubstituted benzene ring is reacted with the dehydrated form of succinic acid, which is nothing but the anhydride form of succinic acid, in which the succinic acid remove one water molecule from its structure and the cyclization happens. Now the benzene and succinic anhydride is reacted in presence of AlCl3, which is nothing but the Friedel-Crafts acylation reaction. In acylation reaction, the acyl group is attached on the benzene ring, which is our first intermediate after step 1, after the Friedel-Crafts acylation reaction. The intermediate is nomenclatured by 1, 2, 3 carbons, and here the whole structure is known as benzoyl. That is why the name of the intermediate one is 3-benzoyl propionic acid, which is the benzoyl derivative of propionic acid. Now 3-benzoyl propionic acid is reacted with zinc amalgam. The step is known as Clemmensen reduction step. The 3-benzoyl propionic acid is reacted with zinc amalgam and HCl to form the reduced form of the ketone group. Here the ketone group is reduced to the methyl group. The methyl derivatives of 3-benzoyl propionic acid is formed in the second reaction. This is our second intermediate, which is 1, 2, 3 and 4. 4-phenyl benzoic acid. Now the 4-phenyl benzoic acid is reacted with H2SO4. The step is known as the elimination of water or the cyclization step. Here the 1 OH minus from benzoic acid, the 1 OH minus from the carboxylic acid and 1 H plus from benzene ring is removed as a 1 mole of water. And the intermediate generated is known as tetralone. Now the tetralone itself undergoes with the Clemmensen reduction in presence of zinc amalgam and hydrochloric acid, and to form the tetraline. Here the ketone moiety is reduced to methyl CH2. Formed tetraline is undergone to the aromatization reaction in presence of active metals like selenium carbon and platinum to form the aromatic naphthalene, which is the primary member of the polynuclear aromatic hydrocarbons. After the preparation of naphthalene, let's discuss the preparation of anthracene via Haworth synthesis, in which the phthalic anhydride is taken as a starting material. Now we have to synthesize the 3 fused benzene ring. The 3 fused benzene ring are in single planar. Here we are taking phthalic anhydride as a starting material, which already contains one aromatic ring in its structure. It is the dihydride form of phthalic acid. Phthalic anhydride is reacted with benzene in presence of aluminium chloride for the acylation step. The acyl group from the phthalic anhydride is attached on the benzene ring to give the 2-benzoyl benzoic acid is undergone to the cyclization reaction in presence of sulfuric acid and heat. The cyclization happens by eliminating 1 mole of water, which is from 1 benzoic acid and 1 H plus from the benzene ring. The 1 water molecule is removed and 2 ketone containing 1 intermediate is produced. Now any molecule contains 2 ketone molecules in its structure. It is known as quinones. So the intermediate is named after the quinones, 9,10-anthraquinone. This is the ring of moiety of anthraquinone, which contains 2 ketone groups. Now this anthraquinone is undergoes to the Clemmensen reduction and aromatization reaction. The reduction of 2 quinone by using Clemmensen reduction in presence of zinc amalgam and HCl, and after the reduced form of quinone is undergo to the aromatization step, which is happen in the presence of selenium or active metals. It produces the anthracene, our desired polynuclear aromatic hydrocarbons. The synthesis of phenanthrene, which is our complex form of polynuclear aromatic hydrocarbon. It is not complex, but the structure is in angular form, in which 2 benzene ring, 2 fused rings are in same planar and another one is in angle. So for the synthesis of phenanthrene, here the naphthalene is taken as a starting material. Naphthalene is reacted with the succinic anhydride and aluminium chloride for the acylation step. The acyl group is attached to the 1 carbon. See, so after acylation step, intermediate 1 is undergo into the Clemmensen reduction, which is happen in presence of zinc amalgam and HCl. So in the Clemmensen reduction, ketone groups are reduced to form the methyl or alkyl derivatives of itself. So here the alkyl derivative of ketone group is reacted with sulfuric acid for the cyclization step. So after the cyclization, the cyclic form of ketone is present. The cyclic form of ketone is reduced by using the Clemmensen reduction step, which is in presence of zinc amalgam and hydrochloric acid. The cyclic ketone is reduced to form its methyl derivatives, and the cyclic phenanthrene is generated. Now the cyclic phenanthrene is undergone to the aromatization step, which is in presence of active metal like carbonate, palladium, platinum and selenium. And after this aromatization, we can get the desired product, which is our phenanthrene. That's all.